I welcome you all back to this class. We are back again to continue from where we stopped. We have been studying this topic, inequality, and we have been considering different examples on this inequality. We solved the first example that has to do with quadratic inequality that involves less than or equal to. And we solved the second one has to do with quadratic inequality that involves greater than or equal to. So I showed you the shortcut that you can use to solve such inequalities. So this one we want to consider today has to do with absolute value. So we are looking at how to solve inequality problems that has to do with absolute value. We want to solve the inequality absolute value of t minus 3 is less than what? Is strictly less than 2. So this is what we want to solve. But okay, let's just start like this. We need to know what this absolute value is before we'll be able to solve this problem. So what is the definition of absolute value of a particular quantity? Now let's look at the definition. By definition, absolute value of x is equal to, by definition, absolute value of x is equal to x if x is greater than or equal to 0, and it is minus x if x is less than 0. This is the definition of absolute value. Why are we bringing it in here? Because the problem we want to solve has to do with absolute value. So we need to interpret this absolute value before we'll be able to solve the problem. We are going to consider case 1. Case 1. So what is the case 1? We use the first definition, right? Okay. If t minus 3 is a positive quantity, a number greater than or equal to 0, right? If it is greater than or equal to 0, then absolute value of t minus 3 less than 2 will imply t minus 3 is less than what? 2. Case 1 is that absolute value of x is x if x is positive. So remember, x is the quantity inside the absolute value. What is the quantity inside this absolute value? The quantity inside this absolute value is t minus 3. So t minus 3 is acting as x in this definition. So which means that the case 1 is that, let's consider the case if t minus 3, if this quantity inside this absolute value is greater than or equal to 0, then by definition the absolute value of it will be the same quantity. So I say if t minus 3 is greater than or equal to 0, then absolute value of t minus 3 will be the same thing as t minus 3, and we are going to have less than what? 2, as we have it here. So we can easily move minus 3 to the other side. It implies that t is less than 2 plus what? 3. If I move minus 3 to the other side, which implies that t is less than what? 5. So this is what we now got, which implies, so this thing implies t is less than 5. That's all numbers less than 5. We have strict inequality there. So all numbers less than 5. So which means from 5 down to negative infinity, you are going to have open bracket negative infinity comma 5 open bracket. We are using open bracket because we have strict inequality, right? Less than. So this is the first case. We are going to look at case 2. This is case 2. If the quantity inside the absolute value happens to be a negative number, we say that if x is negative, absolute value of x will be what? Minus x. X is whatever you have inside the absolute value. What you have inside this absolute value is t minus 3. Okay, let's consider the case where t minus 3 is negative. So if t minus 3 is negative, how do we say that something is negative? That you say that it's less than 0. If t minus 3 is less than 0, then what does this tell us? It tells us that absolute value of t minus 3 less than 2 will mean the same thing as, because if this quantity is less than 0, by definition, then this absolute value of t minus 3 will be what? Minus of it. So minus of it. So we are going to have minus of this quantity inside the absolute value minus t minus 3 will be the result of the absolute value, because we assume that is less than 0. If the quantity is less than 0, the absolute value is minus of it. If this quantity inside the absolute value as t minus 3 is less than 0, then the absolute value of it is minus of it. So we are going to have minus of t minus 3. Of course, we have less than 2 here. So this simply implies we can open this bracket, right? So if you open this bracket, you are going to have minus t plus 3, isn't it? If you use this minus to open this bracket, less than what? 2. This is what we have, right? Okay, then this we are going to have minus t. If I move plus 3 this side, it will change to minus, right? So this implies that minus t is less than 2 minus 3 will give me minus 1, isn't it? So you are going to multiply both sides by what? I want to clear this negative at t. So let me multiply both sides by minus 1. So this implies, so you know, if you multiply both sides by both sides of inequality by a negative quantity, the inequality will reverse, right? So if I multiply both sides by minus 1, so I will say minus 1 times minus t will be positive t. The inequality will reverse from less than to greater than. Then if I multiply this minus 1 by minus 1, I'm going to have positive 1. So I'm having that t is greater than what? 1. So which is simply equal to numbers from 1, numbers bigger than 1. So 1 is not among, because we have strict inequality. Numbers bigger than 1 up to infinity. So we are going to have open bracket at 1. We are going to have open bracket at infinity. Remember, you cannot use a closed bracket at infinity, because infinity is not a real number. So we are going to have open bracket at 1 as well, because we have strict inequality. So we got the first thing we got is that we got the first solution we got is minus infinity comma 5. That's the one we got. Then the second one we got is 1 comma infinity. That's, we are going to take the union 1 comma infinity. So this gives us the general solution of this problem, of this absolute value inequality. So this brings us to the end of this class. So I'm going to explore more examples on this. See you in our upcoming class. Bye.